guys. Welcome to the day 2. I hope you enjoyed yesterday. So as we kick off this conference, I encourage you today to engage more with each other, with speakers, and to ask so many questions them so you can learn and gain knowledge and to make most of this conference. So now, up next is Jelena with her topic, Front-End Microservices. So Jelena is full-stack developer at Epam Systems. She is agile practitioner who is skilled in PHP, Java, and as I said, microservices. So welcome to the day 2.
Thank you. So today I would like to talk about Microfrontends, which is a microservices approach to front-end part of our applications. So we already got some introduction, but I would like to also introduce myself. So I'm Jelena. I'm working within EPAM for 7 years now. Other than that, I have a bit more than 10 years of experience in developing web applications mostly. My stack is PHP, Node.js, TypeScript, JavaScript, Angular mostly, but also I worked a bit with React and Vue. Besides development role, I also had Scrum Master and have Scrum Master role and a team lead role. I worked with web applications, desktop applications, mobile applications, but hybrid applications. I didn't do native mobile development. So today, as I said, I would like to talk about microfrontends. But before we switch to microfrontends, I would like to go a bit through history and see how did we came today to have microfrontends. So, way back in history, we had big monolithic applications. We have database, backend, frontend, all contained in one big code base, one huge big team working everything. And we have tightly coupled components in such applications. All parts of system were relying one on each other. So, for example, making some change or some small bug fix in such applications was a pain. To deploy just some small bug fix, we would have to deploy whole application, which is time-consuming, as you know. I would just mention we still have monolith applications. It's mostly legacy code, and it has some advantages. Working with monoliths has simple development. Since everything is one code base, development is faster. Performance, we can gain performance because since we have one repository, every components are communicating inside of one application, so it can be communication can be faster. Testing is simplified. Since we don't have distributed system, we have everything in one place, so it's easy to implement, for example, end-to-end testing. And debugging is easier. When we have everything in one place, in one monolith, if we have some bugs, some error, we can easily trace where that error came from, since everything is in one place. But since applications came more and more complex, more bigger, we have a situation where development is actually slower, because every developer has to know everything, where everything is placed. For example, also scalability is a disadvantage. If we, for example, have a need to scale only one part of our application, it's hard with monolith because we have to scale whole application. So that is time-consuming. Reliability. If we have some issue on just one part, for example, one issue on backend, that can take entire application down. Next, lack of flexibility. If we start working with one technology, we have to stick to that. It's extremely hard to import a new technology or use something else because that will require refactoring all existing code. And also deployment. If we have a huge application, deployment becomes very time-consuming, and we have to redeploy every time whole application. So naturally, maybe in recent history, and when I say recent, I mean maybe 5 to 7 years, we got splitting or separation of concerns to backend and frontend. So, and this was a good improvement. We got front-end applications. We started to get some frameworks. Backend, on backend, we also had some, backend had its own responsibilities. But despite this division, we still have, I would say we still had monolith. We just had two a bit smaller chunks of code bases. And this is where microservices were introduced, created to solve main issues, main disadvantages of monoliths. So let's take a look at microservices. It was mentioned first at 2011. Of course, on developer conferences, but it started to be widely used at 2016, I think, and widely adopted on backend only at first. So we had on backend we had microservices approach applied, where our monolith backend is split to smaller repositories. For example, we have one service and one team working on that service only. For example, product service. We had a second service, for example, search service, and another team is working on that service, and so on. Service C, we don't have limitations on how many microservices we will have. What is good about this is that each team can choose each tech stack which suits best for that domain, that business logic. Microservices communicate usually over APIs. Usually it's a REST API, but also we can have subscribers, listeners, message queues. And front-end is communicating with this web services, backend services through API gateway. So this was a huge improvement, but at this moment we still have front-end as monolith. We did get some great frameworks for single-page applications like Angular, React, and so on. But it still is a monolith on the front-end part. So this is where we come to microfrontends. Microfrontends is same as microservices. It's microservices architectural style applied on front-end technologies. So we have, if we have one front-end application, big, it can be decomposed to individual, what is important, loosely coupled micro applications. And each micro app can be deployed, tested, and built independently. And so we just have multiple smaller code bases that are owned by different teams. So here we have an example on how would it look like if we have microfrontends and microservices. They still communicate over API gateway, sorry. And I would say what is the biggest gain with using microfrontends with microservices is that we have teams that are formed not by their technology, by their tech stack, but by their domain specialty. Sorry. So they are vertically sized. They develop feature end-to-end from user database, from user interface to database. So we don't have teams. For example, we don't have front-end team, we don't have back-end team and database, but we have team, cross-functional team, consists of, for example, of one front-end developer or multiple front-end developers, but also back-end developers, data science engineers, QA engineers, and so on. And what is good about this, that based on the domain knowledge, team can choose what tech stack is appropriate for that domain. So what are benefits of microfrontends? We have better flexibility. Since we have smaller code bases, we can build them, test them, and deploy independently. We can also do update independently. We have technology freedom for each microfrontend, so we can choose one framework for one, other framework for other service, microfrontend. We have multiple smaller code base, which means we can maintain them easier. Scaling every microfrontend is much easier, and in the end, that means that we can easier scale whole application. Our teams and systems are autonomous, which means they can operate with minimal dependency. Ideally, it would be that they don't have dependency on each other at all, but in practice, they do have some dependency, and we will see how can they communicate. And also lower, easier entry for newcomers to projects, since we have small applications with, which are responsible only for one domain. It's easier for newcomers to get to give fast, what's the word? They can more fast go into a project. So how do microfrontends works? Basically, we have one application which acts like a host for our microfrontends, and usually those micro applications are called remotes. So our host will serve as a parent to those microfrontends. So if we have one big application, sometimes it makes sense to split this application based on page. So every page would be a separate microfrontend. Also, we can create individual fragments for the page. For example, header can be one microfrontend, footer can be other frontend, search box can be third microfrontend, and so on. And also, we can decompose our application by feature or domain. So in this example, we will have 3 microfrontends, which are assembled in one whole application, and one team can have one mission and using React. Second team can have different mission and use Vue.js and so on, AngularJS. I mentioned that we somehow have to assemble those microfrontends within our host application. There are multiple options for this. We can have native approach. For example, routing. We have our host application, and we simply use most simple native HTML routing to navigate through different micro frontends. And this approach is for traditional web pages, not for single application pages. Theoretically, we can use iframes. So every micro frontend will be loaded in one iframe. But as you know, I believe you know, that iframes are affecting main thread, which will have a major impact at performance. And also we can use custom web elements, which were become available in HTML5. But with custom elements, there is one disadvantage, and that is that we cannot, they are not very flexible. So for example, if we want to have a custom element, for example, for sorting, for table able to sort something, okay, we will create custom element. If we want to create collapsible table, we will create a custom element, but we cannot nest custom web components. So if we want to have sortable table, which is also which we can also filter, we cannot do that flexibly. We would have to create third web element. I think this approach with meta frameworks at the moment has it's most possible, and it's making possible to combine different pages regardless of which library is used for them. And today, community is growing fast, and we have, more than 10 web meta frameworks for microfrontends. I mentioned only two mostly used. It's single SPA, single page application, which allow us to bundle load the different frameworks. For example, React, Angular, Ember, Vue, all frameworks can be assembled as one application. And the second one is Webpack Module Federation, which is where we are able to have separate builds for one single application. As I mentioned, in ideal case, our microfrontends will be independent and they don't have to communicate. They don't rely on each other, but in practice, that's not the case. Sometimes they have to communicate, and we have few options here. We have web workers, which is a great way for a web content to run JavaScript in background. They don't affect main thread, and each micro application can have different worker API. So the biggest advantage of this approach is that we are not that it's run in separate thread. We don't affect main thread. We can have props and callbacks, where we have parent component and its child components, and communication is like set in a form of a tree, just like in React. And of course, event emitters, different components that can talk to one another by listening and responding to any change that is emitted. So when micro frontends are a good idea in medium to large projects, because their big advantage is scaling, easy scaling. So the style of building micro frontends is ideal for scaling development, and such makes a good fit for a large project with multiple teams. Also, micro frontends our idea which shines in web projects mostly. I didn't see, I think, any example in desktop application development with microfrontends, and also with developing iOS and Android applications. It's hard to implement this approach because they are monolithic in their fashion, in their nature. And productivity-focused projects. Since we're having vertically sliced teams, this adds up to productivity, but it also adds some costs and some complexity in coordinating those teams. And when micro frontends is not such a good idea, it's not a good idea when you don't have a clear vision of your domain, what your application will grow to or what will do. Because then you cannot effectively create vertically sized teams. And it's not such a good idea for small projects. It can overcomplicate things and can be overkill for such approach, for such applications. Thank you. So now, do you have questions? Comments? Yes?
So you mentioned like a search bar or footer or just a second. 1 second. I don't think it's turned. Oh, yes. So you mentioned search bar or footer or some other component that will use a different framework to be built on. So do you have any examples where specific frameworks do a better job at a specific component that they're being, that you're building? Like
yes.
The actual difference?
No, maybe it's really depending on business requirements. For example, if you have a lot of a big DOM tree, I would say, but that's my opinion, React would be a better fit than, for example, Angular. We will have better performance with React.
Okay.
And of course, I think it's worth mentioning that you have to take account into what your team has knowledge on what stack.
You raise your hand first. You want to ask a question first? Yeah, I want to ask a question also, so yeah.
I also have a question about about your web example with components created on different frameworks. Because usually when you have front-end, you have also some architecture, global state management, and some data passed all around your front-end. And you mentioned that micro-frontends communicate via API. Maybe I understood you incorrectly, but you also mentioned that it is a REST API, probably.
No. This is, yeah, I think I was not clear enough. This is for microservices on backend. They communicate over API, not micro-frontend.
How do micro-frontends communicate with each other?
So via web workers, or props and callbacks, or events.
Thank you.
So here, mostly it was mentioned about single-page applications, and since in recent years we have seen development of back to server-side rendering, especially with Next, Nuxt, and other meta frameworks around their respective libraries, how would that fit naturally? Would it fit naturally with the microfrontend, like microfrontend architecture? Since it would make sense, since those frameworks, meta frameworks are server-side rendered, and they have their dedicated servers.
Yes. You have you have an option of choosing whether you will choose a server-side assembly or client-side assembly. So it can be applied.
Okay, thank you. One more question, if that's okay with the mediator or whoever is managing this. You mentioned, so we have the flexibility and the option to choose and to work with multiple frameworks in microfrontends. Would it be actually maybe a huge negative to have multiple frameworks? How do you manage all those different technologies? And would it add so much maybe unneeded complexity? It's not up to the architecture itself. Maybe decoupled components is a good idea, but having different technologies all in one place, and how would you manage that complexity?
Yeah.
I mean, it's probably a con at some point.
Yes, I see your point, and I think it has to be decided depending on current state of project. For example, in my experience, I had a case when we applied microfrontends, and we started to use Vue for every component. And then we had some heavy calculations and generating PDF files, sorry, where Vue was not fast enough, but it was slow. So we switched to React, which was behaving very, very good. So, but you are right, it adds complexity in coordinating teams, communicating between teams.
Thank you.
Anyone else? Yes.
So, from your experience, what is the threshold where you actually decide, that this is a good idea? Like, from now on, we're gonna employ 5 more people to work on the search bar or something. I mean, like, it's hard for me to imagine a point where I'm, creating a separate team to do a single component. I mean, how large has a, project has to be?
Well, for example, I will not say the name, but main music streaming application is using this approach. The leading social network also, because as you know, for example, when they just started, we could just invite some friends, communicate with friends, we have chat, but today we have pages, we have videos, shorts, all in one application. Imagine when you have to do with one framework, with one team, all of those components.
So it's like corporate level.
Yeah, very, very large applications. As I mentioned, I believe in small applications or medium applications, it would be overkill. Anyone else?
Yeah, so I just wanted to ask, let's say that you're working on a big e-commerce app and it's already microservices on the backend. How would you start with translating frontend to microfrontend?
Gradually, not all at once. In my experience, I had that project. I mentioned it earlier, but you have to maybe pick one new feature, and let's say with this feature we will start using microfrontends, and we will implement this with our legacy code. Okay, and then when you work on some old feature or improve it, okay, let's slowly refactor it and move to microfrontends. Doing everything at the same time, I think it's not a good idea. It will require some time to refactor.
Because I found a lot of same similarities. You said specific domains, so you will also have like search, you will have payment, you will have checkout, and I think that approach of microfrontends would be good fit for, let's say, big e-commerce app. So just wanted to, yeah.
Yeah, if it's enterprise
Yeah.
scoped, yeah. I believe so.
Thank you.
Thank you. Anything else? If that's it, thank you.